just a quick refresher here. So you guys are, the idea is to be able to create a graph, interpret a graph, including the meaning of the slope, and recognize linear, quadratic, and inverse functions. And we've done a bunch of things. And by now you should have this out. And in fact, let's kind of make this a rule that by the end of the TED Talk, your binder should be open. It really shouldn't be 116 when you just finally realize, oh, Mr. Bennett's going to start with us opening our binders today. What a crazy idea.
Are we going to watch TED Talk today?
Because I like them. I think it's important to learn something different, too. I can go right into this if you want. Sounds good? Yeah, Kayla, you take care of that. But at the very least, I should expect you to have your binders open by the time the TED Talk is done. I know I can still have that expectation ready. And in fact, open to where we left off would be a good idea. Okay, so we are creating graphs, interpreting them, and recognizing what type they are. Now I think, if I'm not mistaken, we went through all this. We talked about curved graphs, linear graphs, how to plot graphs. We talked about how to do slope, right? And this is the teaching part now. Now it's listening to me. It's 116. It's Mr. Bennett time. Okay? I taught you how to do slope. You're going to get more practice time today. I taught you about linear graphs, quadratic relationships, and inverse relationships. And we did these sort of as a class refresher. We did this first exercise where you interpreted the graph. You did some reading of the graph. We calculated slope. We talked about units of the slope. We talked about the meaning of the slope. And I think you were to have number 2 done for today. Am I right? Is that where we left off? I think I said...
We said have the graph done. Yeah, you said the graph done.
Get number 2 graph done? Is that what I said?
Yeah.
Okay, so you have number 2 graph done.
Yes, sir.
Okay, excellent. So let me just do my graph quick and show you just how long it should take to do this graph. Right? So we've got the volume. It's going 0. Did you guys go by 5 or 10? Probably 10. Will 5 work? Yeah. Okay. So that should be 30, 40, 50, and here it's, oh, that's, okay, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so 10 and 11. 10 and 11 is like about there. 20 and 18.9, thank you. 20 and 18.9 is like there. 30 and 26.8 is like about there. 34.7 is almost 35, and 42.7 is like about halfway. Okay, are they pretty much in a straight line?
Yes.
Pretty close. Perfectly straight line?
No.
Yes.
Perfectly straight?
Yes.
Perfectly straight, Kaylee? No. Are they in a straight line? Not are they touching a line. I mean, they are touching this, every one of those vertical lines, right? They should not be in a perfectly straight line. Now, I tried to randomize a little bit. I should probably do a better job. So what you need to do is get a ruler or some sort of straight edge that you can manipulate, right? And you're going to do this, right? You literally put on a ruler that touches as many or goes through as many or is as close to as many as possible. Oh, now I really screwed up, didn't I?
Is that not a perfectly straight line?
See, it's hard to do up here. You guys have it easy.
Does that not make it perfectly straight line?
It's pretty close, right? Now, is it always going to be nice and straight like that? I'm going to go with that. That's literally what you do. You take a ruler and you draw a line that describes the trend, the overall trend in one straight line. Again, you do not connect the dots. Do not connect the dots.
You just did.
No. I did not do this. I did not go like that. I didn't connect them with a series of lines. I drew a single line. There is a difference. I drew a single line. I did not connect them with individual lines. Braden, I need you looking up here. If you can't look up here, we'll have to find you a spot that you can only look up here. You have to. You can't be looking back there. You understand? It's not allowed. Okay, so we've plotted them, we've drawn the curve. Describe the resulting curve. Is it a line or a curve? It's a line. Find the units of the slope of graph, and what is the name given to this quantity? So the units are, the y is grams, and the mass is, or sorry, the x is cubic centimeters. I'll get it right eventually. So the units are going to be grams per cubic centimeter. And what do we measure in grams per cubic centimeter? Density. Right? Okay, what is the value of the slope of the line of best fit? Are you going to get exactly the same value as me? No, you're going to get slightly different. Adam, what's going on? Seriously, you have to look up here. So, again, I was saying, is your value of slope going to be the same as mine? No, it's going to be kind of close. It depends on which points you pick. These points are pretty much lined up perfect, aren't they? Okay, so it's not going to matter. But when we do the lab in a couple days, your data points are not going to be perfect. It's going to be a little bit more like this kind of thing. And you're going to have to draw a line that best describes those and pick data points that work. Now, if you can, pick points that are actually on your line of best fit. If you can't, then you're going to have to pick points that make sense. Like, for example, well, maybe that one there, right? Like if there are no data points that are on the line, you have to make data points on the line. We are lucky we have those ones. Which ones did I pick? Those ones. And now you might have different data points. Okay, so how do we find the slope? Rise over run, change in y over change in x. So what's the y value right here? This is the 51, this is 42.7, right? So 42.7, subtract, the y value here is, that one there, 18.9, over, the x value here is 50, and the x value here is 20. Okay? You have to be able to do this, like real soon, on your own. You can do this. This is a review of grade 10. 42.7 minus 18.9. Oops. And divide that by 50 minus 20, I can do in my head, is 30, and you get a slope value of? Exactly. 0.79. What if you got 0.8? Close enough. What if you got 0.75? Close enough. Please don't yell out a bunch of numbers. As long as you show me what data points you're using, and you show me your work, as long as it's in the ballpark, I'll give it to you. I came up 0.793 actually, yeah. Yeah. Close enough, really. Anywhere between about 0.5 and about 0.9 is close enough. Okay? I don't care about the number, I care about, can you show me how you did it? And if you do that right, the number's going to work out for itself. Okay? So that is the value of the slope line of fit, and that's going to be 0.79 what? What is the units for the slope? Grams per cubic centimeter, exactly. Okay, so write an equation relating the volume to the mass outcome. Now, did I do this with anyone, like individually the other day? Again, I have to keep asking this because I got those two classes I have to keep track, right? Okay, so we're going to write an equation. Y equals mx plus b. You guys have done that before, right? The y and the x stay, so it's going to be y equals, what's my m value? 0.79 x. Now, what's the y-intercept? Well, we have to estimate. Now, there are mathematical ways to do it. I used to teach to grade 11s, and usually they looked at me like I was talking Chinese or something like that. Okay? Especially when they didn't speak Chinese. The Chinese people in the class understood what I was saying, because I was speaking Chinese. So let's just estimate, shall we? What's the y-intercept there? If that's 0, and that one's 5, then what's that one going to be about? About 4, maybe? Maybe 3. This is 5. That line is 5. So 0, 1, 1, 2, 3, maybe 3.5. Let's say 3.5. So 0.79x plus 3.5. So all I've done is just estimate that. from the graph. Now, shouldn't the y-intercept be 0? Because what are we doing here? During an experiment, a student measured the mass of 10 cubic centimeters of ethanol by pouring it into a graduated cylinder. The student then measured the mass of 20, and this way the data table collects. So they're taking 10, 20, 30, 40, 50 cubic centimeters of ethanol, and they're measuring how much it weighs. So if I've got 0 ethanol, how much should it weigh? It should weigh 0. But it doesn't. When it's 0, it weighs 3.5. What's going on? Exactly. Oops. The cylinder has a mass of 3.5 grams. What should the student have done? Subtracted the weight of this. They should have weighed the cylinder to begin with and either subtracted it every time or what we call zero the balance. You put the cylinder on, you press the button, right, and it zeroes it. It sets it to 0. Okay. Bonus challenge question. If they didn't, if we did that properly, if we subtracted that 3.5 anytime, would it change the value of the slope? It would what? It would just move the whole line down? You're absolutely right. All it would do is make the line like that. The slope remains the same, and that's because the density of the ethanol is 0.79. It doesn't matter whether it's a big graduated cylinder, a tiny graduated cylinder, a paper cup, Jimmy cracked corn, I don't care. The density of ethanol is 0.79. Does that make sense? Yeah? The cylinder has a mass of 3.5 grams. I apologize for my... Yeah, if Lynn has a mass of 3 SG. There we go. 3.5, I guess, right? Does that make sense? Is that good? Noah, I'm speaking English? Yeah? Okay. How do you feel about try number 3? Giver, you got like 8 minutes. Okay, so here's how to do it. Again, this is the last practice one. After this, the expectation is you can do this. Okay, the bar has been raised. If you still can't do it, you want help, come and see me. Ask us nothing for help. We'll help you. But the expectation is you can do it on your own. Okay, I've taught it. You need to learn how to do it by now. So during the demonstration, an instructor placed a 1 kilogram mass on a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass and measured the rate at which the mass gained speed, or was accelerated, for each force applied. The results of the experiment are shown on the table. So the teacher gave this object a push. What's the quantity that they have control over? The push or the acceleration? The push. So the push, the force, is the independent and goes down here. And the acceleration is what is measured, and it goes here. Now, some of you sort of noticed that this line here, this line here are kind of darker, and you use that for your 0, and that's fine. Others of you didn't notice that. It's not really obvious. That's okay. Okay, but I'm going to do that just because I know what happens when you don't. So 0, these go up by 5s, 5, 10, 15, 20, 25, 30. I got to go up to 30. This will work as well. So this is 0. I almost messed up. 5, 10, 15, 20, 25, 30, 35. Don't fix it if you did it with this is 0. It's fine. It's fine. Don't fix it. You're good. 5 and 4.9 is like right there, just below. 10 and 9.8 is like just below. 15 and 15.2, now it jumps above the line. 20 and 20.1. 25 and exactly 25, right on the line. And then 30 and 29.9, just below. You draw your line, Travis, are you watching? No. With a ruler, you draw your line of best fit. No. It has to go through as many points as possible, or as close to. And it's your opinion. It's kind of like an opinion question. Okay, so you're going to get slightly different values than most. And I'm making a mental note right now. I want to change this data so that they're not all lined up so nice. I'm going to adjust to the smidge to force kids into doing a better job of that. Okay, then you Pick points that are on the line. You might have different ones. Okay. I had someone ask about how do I know which one's x1 and which one's x2? That's a slope thing. That's grade 10. You got to know that by now. Okay? I'm going to show you again, but I expect you to know this. This is x1, y1. This one is x2, y2. It's always from left to right. Take your y2s and subtract. So this y value here is 20.1. 20.1 minus this y value is 15.2. And the x values are 20 and 15. Okay, so 20.1 minus 15.2 I think is 4.9. I can do that in my head. I think I did that right. All over 5, which is probably 0.98. I would expect everyone to get it right. I've shown you how to do it. What if you got 0.99? What if you got 1.1? It's okay as long as you drew a line, showed me what points you used, and applied the slope formula properly. The process is what matters. I don't care so much about the number. Okay, 0.98 what? Oh, we got to estimate the y-intercept. Now mine turned out to be 0. Pretty much right at 0. I saw a few other people. Some had -2, some had -1, some had -0.5, and so on, right? All fine. It all depends on how you graph it. All fine. Okay, so write the equation. So we're going to say that the slope is 0.98 and the y-intercept b is 0. Write the equation relating the force and acceleration that result from the graph. Y equals mx plus b. So y equals m 0.98 x plus b, which is 0. Should I write it?
Yes.
I don't need to, but I'm going to write it. And Lawson, I told you why. Why do I write it?
So you know that we know what we're doing.
Exactly. You have to convince me that you know what you're doing, right? So if it's 0, if I just leave it off, well, how do I know that you know it's 0 or you didn't just leave it off, right? So it's probably a good idea on a student's part. If you think it's 0, tell me that you know it's 0. You just put like -1. Yep. Yeah. You could put plus -1, I guess, if you want. But yep. Good question. Okay. Find the units of the slope of the graph. What are the units here? This is acceleration, so this is meters per second squared. This is force, so this is newtons. So your units are y divided by x, meters per second squared over newtons. Does anyone know what you measure in meters per second squared over newtons?
Absolutely.
It's actually the inverse of mass. It's actually the inverse of mass, which really doesn't have a name. So in this rare example, the meaning of the slope is something that really doesn't mean anything. The only way to make the slope mass would be to move the force and the acceleration and sort of flip it. Is that okay to do? You almost always put the independent down here, but sometimes you want the slope to make sort of sense, and so you just say, you know what, I'm choosing, I know the difference, but it's no rule, it's just a convention. There's no reason why we can't flip these two, like just exchange them, and that way the slope would actually turn out to be the mass, right? And in fact, that's exactly what you could say. It's coming up a little bit later in electric fields unit. If you're trying to find the mass of something, that's one way to do it, is to find the slope.
Find this inverse of mass or any of those.
Yep.
What?
Well, the inverse of the mass here is 0.98.
Okay, but what is?
Oh, it's one over the mass. So you'd go 1 divided by 0.98 to find the actual mass. If you didn't get this last part, that's fine. That's like extension down the road. Don't worry about it. Okay? Yeah, don't worry about that. Okay, so what have I shown you? I reviewed how to make graphs. I reviewed how to do slope. I taught you how to find the units of the slope. Get a little cracked up here. What else did I do? Go to the 3 relationships, that kind of stuff, right? Wouldn't it be nice if we didn't have to go through all this mess? Wouldn't it be nice if there was some technology, some mystical, magical technology of the future that could do this? Called a spreadsheet. In the next 25 minutes, you're going to learn how to do it on a spreadsheet. Okay? Excel. So what I want you to do is, now there's a whole bunch of you, so there's probably not going to be enough laptops. And it kind of looks like they, oh, which is something else. Okay, so you're going to have to sort of, I would suggest one per table tonight, some that can double up. Okay, log in, and I'm going to give you another sheet.